All right, so the question asks, write a balanced molecular, total ionic, and net ionic equations, and use this to determine if a reaction occurs. So we're going to start with the molecular. All right, this is the equation that shows all the reactants and products as if they were intact and undissociated compounds, meaning that they haven't dissolved yet. Okay, we're given potassium fluoride and strontium nitrate. The first step is to just convert those into their actual form. Okay, so I'm going to do the molecular equation. I'm going to do down here. Okay, potassium has the symbol K. Fluoride is F. This is their formula, and we're adding to that strontium nitrate. That's SrNO3. Okay. If you look up here at the molecular equation, okay, this is a double displacement reaction, right? Meaning that the cation in one is displacing the cation in the other. So Ag is displacing Na, right? And they just swap their anions. Okay? So we're going to do the same thing here. Our cation here is K, right? And our anion is NO3, so we'll have KNO3 plus SRF. And I totally didn't make this mistake. There. Okay. We want to make sure that this is balanced, right? So we have KF, we have F2 over here. So we're going to need to balance this by putting a 2 there. If we put a 2 there, that means we have 2 potassiums. We need to put a 2 here. Okay? So now this is balanced, right? That's just a balancing problem. All right. We also need to show if they are soluble or not. All right. That means we need to show if they are aqueous or if they are solid. Okay. These ones tell us for the beginning, potassium chloride is aqueous. Strontium nitrate is aqueous. Let's put an AQ. Here is where our solubility rules become very important. We just formed KNO3. Imagine that you have your A and B sheet. Is KNO3 soluble or insoluble? Soluble. It's a nitrate, it is soluble. So that means it's going to be aqueous. Is strontium fluoride soluble or insoluble?
Insoluble.
Insoluble.
What?
Right. It's group 17, right? Fluorine is group 17, but strontium is one of our exceptions, right? That's the SRA in Caspra, right? Caspra. So, if this is insoluble, what symbol do I put here?
Solid.
Solid. I'm putting an S. So this is solid. Okay. So that is the molecular. All right? Let's now write the ionic equation. So I'm going to write the ionic equation up here. Okay? The ionic equation is exactly what we just did, but now we're splitting everything apart into its ions. Okay? So I have 2KF. So I'm going to have 2 sodium ions. They're aqueous. Potassium, thank you. Whew, it's been a long day. All right, plus 2 fluorine ions. They are also aqueous. Plus strontium nitrate. How many strontiums do I have? Just one. So I've got plus SR, and SR is a plus 2. It's also aqueous. Plus NO3. How many NO3s do I have?
6.
2 of them. 2 of the entire ion.
Oh, okay.
Right? So I have 2 nitrates, NO3. They are also aqueous. And now we talk about the products. Okay. I have K here, right? K plus. So I have 2 K pluses. Okay. NO3s. 2 NO3s. And then, do I have strontium and fluorine ions, or are they together now?
Together.
They stay together because they're solid. So they're no longer ions in solution. They have formed a solid and they are no longer in the water, right? So they're not ions, they are still themselves. They are still this compound, strontium fluoride, and this is solid, okay? All right. So the last part is the net ionic, all right? This is a lot smaller. The ionic equation is almost always really long because you got to write out all of these ions, right? Net ionic, we eliminate what are called the spectator ions. So those are the ions that are not involved in the reaction, okay? So the only things that are involved in the reaction are the ones that produce the solid, right? So on our reactant side, is potassium part of our solid? Nope. Is fluorine? Yes. So fluorine is part of our net ionic. Okay. Is strontium involved?
Yes.
Yes. So it is part of our net ionic. Okay. Is nitrate involved? Nope. Potassium not involved. Nitrate's not involved. So the only thing we have left is the strontium fluoride.
Another question.
Yes, question.
If you were to have another solid which included those ones, the ones we left out, the spectators, we would keep them, right?
Well, you would, except if that was the case, then they would never have dissolved into solution in the first place. Right? Because if they were made of 2 things that both are going to form things that aren't solid, they would have stayed solid in the first place and there'd be no reaction. Yes?
How come potassium is not involved in the net ion?
Because potassium is not part of the solid that forms, right? So there's no, we don't care about it here. The reason we call these spectator ions is because it doesn't matter, like in our problem here, they give us potassium fluoride. But if they'd given us sodium fluoride or lithium or any sort of fluoride, we wouldn't care, right? It has no bearing on the thing that's actually produced, right? So that's why they're called spectators. They're just watching the reaction happen, okay? So the question asks, in order to determine if a reaction occurs, how did we know a reaction occurs?
If two of the elements combine and it form to a product,
And what state of matter does the product have to be?
solid.
Solid. If you get to this point, right, and both products are soluble, right, both products are still dissolved in the water, it doesn't form anything. There's no reaction there, right? They're just going into the water and they're just dissolved. That's it, right? There's no reaction. There's only a reaction if we see some sort of change in the state of matter. So either a solid or a gas forms. Okay? Liquid is weird. That's the scientific way of saying it. But we're looking for solids. Okay? All right. Thank you. Remember to like, comment, subscribe. You guys can share the video. You can also find me on Facebook. I am going around doing the new chemistry comedy tour. It's going to be really coming to all cities near you. All right. Thank you guys so much. Thank you, Celsius.